Hey guys, in this video we're going to have a look at a little bit more of algebra and looking at algebraic expressions that are raised to a power and then raised to another power. So the rule here is when we've got an expression x to the power of n to the power of m, so we're in a sense we're raising x to two different powers. We're involving brackets, so we need these brackets here. We multiply the powers, we end up multiplying the powers. So how does this work? If we look at this example here, I've got x cubed to the power of 2. If I was to write that out in full, what it means is everything inside the brackets, whatever is inside the brackets, is being squared. So I've got x cubed times x cubed. So x cubed squared is rewritten like this. So from our previous rule we know that if the base is the same we add the powers. So x cubed times x cubed gives us x to the power of 6. Let's have a look at this second example. 2x to the power of 4 is being raised to the power of 5. So if I were to write that out in full, it would look like this. So we've actually got 5 of those being multiplied. Okay, so now I can see I can just multiply these 2's. Okay, so 2 times 2 times 2 times 2 times 2 will give me 32. And x to the power of 4 multiplied out 5 times will give me x to the power of, I'm adding these powers here, so 5 lots of 4 is 20. So if we go back to the original question here, essentially what we're doing is we're multiplying those powers. So 4 times 5 will give me 20. We are also raising that 2 to the power of 5. So you do also need to do 2 to the power of 5. So 2 to the power of 5 is 32. So we want to start going from this to that. So when you're given a question, unless you're asked to write it out in full, you don't need to write this step here. We can just go straight to this answer here. Okay, this third example. We've got 4x to the power of 5 raised to the power of 3. So that 4, I need to work out what is 4 raised to the power of 3, and that is actually 64. Then we've got x to the power of 5 to the power of 3. So I'm going to multiply those powers. That will give me 15. So 64x to the power of 15. Okay, this last example, a little bit more trickier, but not so much. Everything inside the brackets has been raised to the power of 3. So that 2, I'm going to raise that to the power of 3. So 2 to the power of 3 will give me 8. 8. X squared to the power of 3, so I'm multiplying those two powers, will give me x to the power of 6. And then I've also got another variable here, y cubed to the power of 3. So 3 times 3 is 9. So I would get y to the power of 9. So that's powers of powers. I just want to recap multiplying and dividing with powers. Okay, so remember the rule with multiplying with powers is that we add the powers. So if I've got an example here, of course we're going to multiply the coefficients first. So 3 times 4 give me 12, and then because the base is the same, the base is x here, I'm going to add the powers here. So x to the power of 5 times x squared will give me x to the power of 7. Okay, another more complicated example here, but let's just follow the principle. So the coefficients I multiply first, so negative 2 times 8 will give me negative 16. And then I'm just finding the bases that are the same. So I've got x squared here times x here will give me x to the power of 3. Notice that single x, there's actually an invisible one there. We don't normally put it in. but if I add 2 to 1, I get 3. Then I've got my y's. Okay, so y squared times y to the power 7. 2 plus 7 is 9. And then I've got z times z cubed. Gives me z to the power of 4. Okay, and the last rule with powers was when we're dividing expressions that have powers. So the rule is, if the base is the same, we subtract the powers, and it's the power in the denominator of the expression being subtracted from the power in the numerator. So if I look at this example here, we do need to do this division. So 14 divided by 21. So those numbers in front of the algebraic part you want to simplify. So I can see that both of those are divisible by 7. So I get 2 over 3, or 2/3. And then I've got x to the power of 6 divided by x to the power of 4. So 6 minus 4 will give me 2. 6 minus 4 equals 2. So I get x to the power of 2. Now, one thing to think about is what happens when we've got this sort of scenario going on. I've got x to the power of 6 divided by x to the power of 8. I still apply this rule in that it's the top power minus the bottom power. So 6 minus 8, that actually gives me negative 2. So my answer is x to the power of negative 2. What does that mean? Well, if I were to write that out in full, it would look like this. Divided by, I've got 8 of them here on the bottom. What's that? 1, 2, 3, 4, 5. Yep. And then remember, we can just cancel these 1x for 1x on the top and the bottom, like this. And what I actually end up with is x squared in the denominator. So this is the same as saying 1 over x squared. Okay, so when I've cancelled out all my x's in the numerator, I need this one here. Okay, so 1 over x squared, which actually is the same as x to the power of negative 2. So that's where that negative sign comes from. It's the fact that it's 1 over x squared. Okay, let's have a look at this second example here. 4 divided by 18, I need to simplify that. So I get 2, so dividing both by 2, so 2 over 9. Then I've got x squared divided by x to the power of 5. 2 minus 5 is negative 3. So I can write it like this. So 2x to the power of negative 3 divided by 9. That would be my final answer. Or you could write it like this. 2 over 9x cubed. So if you were to expand this out in full, such that it sort of looks like this, you would end up with that x squared on the bottom. So you'd end up with x cubed on the bottom. So either this answer or this answer, both would be correct. Okay, this last example here, a few more letters involved here, but we're just looking for the bases that are the same. So I've got x squared divided by x cubed. 2 minus 3 is negative 1. So I'm going to end up with x to the power of negative 1. Y to the power of 4 divided by y squared. So 4 minus 2 will give me 2. So y squared. And then I've got z divided by z to the power of 3. Remember, there's a 1 there. So 1 minus 3 is negative 2. So z to the power of negative 2. So that's one way of writing it. I could also write it like this, or put put my division bar in, I'm going to end up with 1x on the bottom. Then I've got y squared in the numerator, and z to the power of negative 2 means that z squared is on the bottom line. So either you can write your answer like that or like that. So these sorts of problems, these last three problems here, would be at excellence level.